Hi everyone, my name is Dr. Campos-Stein, and today I'm going to talk to you about capillary action. Capillary action is the process that all plants undergo in order to transport water from the roots up to the rest of the plant. This process is made possible because of the unique properties of water, which we will talk about in the next session. As you can see, this is an H2O molecule. H2O molecules are composed of one oxygen molecule and two hydrogen molecules. Because water is so dynamic, it has a lot of properties. One of the properties that it has is adhesion. Adhesion is a process of attaching one thing to another. In plants, it allows for the adhesion of water to the organic matter of plants. This happens when water is introduced through the roots and it goes up the stem and up the leaves, and because the water molecules are attracted to the solid molecules, it's able to travel throughout the plant. Another property of water that helps with capillary action is cohesion. Cohesion is the process of keeping the same molecules of the same substance together. This is the way the water molecules are able to stick together. In the case of plants, it allows for the water molecules to stay together as they travel up the plant. The third and final property of water that helps with capillary action is surface tension. Surface tension is caused when liquids form a sort of layer on the surface of the water that acts as a small film. In plants, surface tension is responsible for helping water keep its shape. When water is able to retain its shape, it's able to stay together, and it's able to travel out the plant, capillary action is possible. Water molecules are very attracted to each other, right? So one of the things that I've seen, and I'm gonna do it right here with you guys right now, is that if I were to dip my finger in here, okay, we have all the water molecules in here. They're in liquid form, but if I go ahead and put my finger inside, dip my finger inside the water, okay, the water attaches to my finger, okay? That is because the water molecules are attracted to the water, to each other in here, but they're also very attracted to something solid like my hand. So when the water molecules meet with the solid, which is the inside of the plant, they're very attracted and they start to attach themselves. And so they're attaching themselves to the inside of the stem, they're able to travel upward, okay? Because of all these amazing properties of plants, okay? So we're gonna stop right now with the knowledge, and now we're gonna try this out ourselves, okay? Okay, so in order for us to begin our experiment, we have to practice safety first. So I'm gonna go ahead and put my goggles on, okay? So that I can be ready for scientific achievement. Materials we're gonna need, okay? So we're gonna be using 3 paper towels, and I got the selected size, so they're already the length that I want them to be, the width. But if you don't have that, you can just get a regular paper towel and cut it in half, and that works just as well. I have 7 clear cups of water. I have some scissors. I have different colors for coloring, and I have my trusty H2O. Okay, so the first thing that I'm going to do, I'm going to grab my paper towels, and then I'm gonna lay them like this. But first of all, let me go ahead and lay this down first, because I want to create a contrast between the paper towel and the table. They're both white, so you know you're not really gonna be able to see. But here you can clearly see my towel, my paper towel. And what I'm gonna do now, I'm going to fold it inward. Okay, so I'm gonna take one edge and then I'm gonna fold. Okay, so there we go. I make a fold and I make sure to crease the edge as I'm going. And I'm gonna keep going forward, and then I'm gonna keep creasing, making sure that I crease all the edge. Okay, and then I go forward again, another fold, and I go ahead and crease. And here on this side, I'm going to bring the opposite side inward, and then I'm going to crease. Okay, so I'm going to go ahead and get this going. Fold them in half, okay, and put them aside, okay. On the side, so I can set up my other materials, okay. So I'm going to go ahead and set up 7 cups of water. What we're going to be doing, we are going to pour water into our cups. Okay, we're going to pour around, what would I say, 3/4 of a cup into our cup, the first cup. And then we're going to alternate. So we're not going to be pouring water into all the cups. So the first cup gets water, then we're going to skip the second cup, and then we're going to pour 3/4 of a cup in here. We're going to skip the fourth one and pour 3/4 of a cup of water inside this cup. And we're going to skip the sixth one. And on the seventh one, we're going to go ahead and pour some of this water, okay? So I'm going to go ahead and choose the colors. So for this experiment, first one, my lime is going to be first, my green, and then this one. Okay. I like this pattern, so I'm going to go ahead and do that, okay? So for my first cup of water, I'm going to introduce 3 drops of the food coloring inside the cup, okay? And I'm thinking maybe I'm gonna add another drop to this one because I really want to make it vibrant. I wanted the colors to pop really good. Okay, so I'm gonna go ahead and add another one of the green ones in here. The blue one I think is good. Maybe another one to the red one too as well. Well, that was 2. Okay, so you can make it as dark as you want. It's up to you. Okay, this is your experiment, and you can go ahead and experiment however you want. Okay, so I have everything ready here. I have my 7 cups of water. Well, not 7 cups of water. I have my 4 cups of water, and in between those 4 cups of water, I have the empty ones. Okay. So I'm gonna go ahead and grab my napkins, the ones that I had already folded, and then I'm gonna cut this in half. Okay. Each one of these napkins is gonna get cut in half. Okay. So you're gonna have 2 equal size paper towels. Okay. We're gonna put them on the side, and we're gonna do the same to the rest of them. Okay. And what I'm doing, I don't know if you guys can tell, right? I'm inserting the scissors right in the middle, like that, and I'm just cutting along the edge. Okay. So now I have 6 folded paper towels. Okay. So once I have these 6 paper towels, I'm gonna go ahead and fold them in half again. Okay. So that I can have this little like upside down piece. Okay. And can you guess what I'm going to do with these? You're pretty smart. You can guess. Okay. So what I'm going to do now, I'm going to go ahead and insert my paper towels. Okay. One half of it is going to be submerged, and the other half, well, not the whole thing, but you know, it's going to be on the. And as you can see right away, we're going to be able to see the attraction of the molecules moving up the paper towel. Paper towels are solid, the molecules are solid, so we have this very big attraction, and as you can see, the water is going up the towel very rapidly. Okay, so let's go ahead and do all of them. Okay, so like I said, the paper towels are solid, they have solid molecules. The water is very attracted to the solid molecule, right? So it's going up, okay? And make a prediction. Think about what's going to happen. What's going to happen with the colors. But this is what really happens when you do capillary, or when trees and plants go through the process of capillary action. The water gets attracted to the inside of the stems and it travels upward because the attraction keeps going, right? So the water sticks together and it keeps traveling up. And that's how our plants are able to get water. So I'm going to leave this here for a while like this and keep an eye out. See what happens, okay?